for the next part, the geometric sequence Rn has a first term 5000 and a fourth term 625. Okay, so we kind of like a same structure like before, but this time is geometric sequence. They label it as R, and the arithmetic sequence they label it as N initially. So A, B, C, D, all arithmetic sequence from that sequence, and this time they combine with a geometric sequence. Okay, so the first term 5000, fourth term 625. Okay, let's break it into the formula. Show that the common ratio is half. So here, so 5000 u4, fourth term is 625, and then u4 is 625 here. 5000 times r to the power of 3. 4 minus 1 is 3. 625, and then we move the other side and we cube root of this and we get half. So I think this one you can do a little bit of algebra, then you can cube root of that using a GDC, and you get the answer. Okay, and the next part, find the value of the 11th term. Quite straightforward, so means u11. So this kind of questions are quite helpful because they give the first term 5000 and somehow they give the common ratio half. We just for E we need to show we get half, and if we did not, we can still use that and still can get the F correct. U11 is 5000 times half to the power of 11 minus 1, which is 10. Okay, so I'm going to use GDC here. So 5000 multiply with, okay, control divide. So this is where you get the fraction. So maybe we need to put a bracket first. So this part is 1 over 2 and to the power, this button next to x squared, power of 10, and we get 625 over 128. So you can leave the answer as a fraction, or if you want to change it to decimal, so you can use control enter. You can see the estimation symbol up here. So they convert that to the decimal, 4.883 significant figures always. And last question, find the first value of Q, which SQ greater than RQ. SQ come from the first part, arithmetic sequence. So we need to change N to Q, and the geometric sequence R to Q. They are talking about the term. This is not the sum. Okay, so the term SQ, I substitute accordingly. U1 plus Q minus 1D. We follow, they give Q, it's supposed to be N. So this is supposed to be UN actually, but we change that. RQ, this is also UN. This time the second one is the geometric. And we substitute, follow what they give. They put SQ greater than RQ. So I'm going to put like SQ 73 plus Q minus 1, 8 greater than 5000 times half to the power of Q minus 1. So when I simplify that, I get 65 plus 8Q on the left side, and the right side 5000 times half power Q minus 1. So we're going to use GDC for this. This means the left is a graph, and we want to see when is the left graph is bigger than the right graph. When that happens means when is the X for this to happen. So I'm going to put it in GDC, control docs. I'm going to add page. So add graph, they open a new tab here. I like to use this function. And let's put 65 plus 8Q. But our x-axis here is X, so we're going to change that to X. So therefore, I get this. I can't see all of it. We can use menu, window, and then we choose zoom fit. Okay, now we can see it a little bit more. Okay, and then now we're going to put another function, the right hand side function. So I'm going to add that, use tab. Put tab, they open a new function here, the new function. So we put 5000 time, okay, open bracket, and then put a fraction, 1 over 2, and to the power of X minus 1. Don't put Q because they don't know what is Q, so we use X and Y here. We see here. So when if you notice our GDC, we can drag, we can see more here. So what they are asking in the question is they want to know when the left function or left equation greater or bigger than. If you see here, the blue, we read through x. So this is the x when it is below. This must be above that. If we go further up, it goes above. Yeah. So let's say we have some x here. So when it happened x here, blue is lower than red. So we want to see when the blue is higher than that. That's bigger. So it start getting bigger at this point. So after this point, blue is higher. So you see blue up here, red down here. Blue up here, red down here. Blue up here, red down here. So we are comparing in terms of x. We look at this part. Okay, so this look at as the x getting bigger, it goes down. This is when x getting bigger, it goes up. So we want to know when it begins. So we want to know the intercept. So menu, analyze graph, intersection. So we know that we just need to trace, put it here, we trace a bit, we got that 6.42. So means the x start from 6.42. At 6.42 it meets. So maybe 6.43 and above. Okay, so what is x again? X is here in the equation is q. What is q again? Q is number of. So we cannot take a decimal value. It must be a positive integer. Therefore, it will be positive 7. Okay, so that will be the answer. Q will be positive 7. Then looking for the term. Find the first value of Q. The first value of Q for SQ greater than RQ. So maybe you put Q7 in arithmetic and you put Q7 in the geometry. And then we must get the arithmetic bigger than geometry. Okay.